All right, so today we're going to be using the Riemann sum definition of the integral to compute this. All right, so first, the Riemann sum definition of the integral is this right here. The limit as n approaches infinity of the sigma notation from I equals 1 to n of f of xi times delta x. Now, what does this mean? So we need to find, first we need to find delta x, all right? Delta x is b minus a over n, all right? Now, b in this case is 4, a is 0, all right? So this is 4 minus 0 over n, which equals 4 over n, okay? And now we need to find xi, all right? Our xi right here is a plus I times delta x, all right? Now this equals, our a value is 0. This equals 0 plus I times delta x. So our delta x is this. I times delta x is 4i over n. 4i over n, which equals 4i over n. This is our xi value. Now we need to find our f of xi value. F of xi. And then this is quite easy. You just put the 4i over n into the x value here. So it's going to be 6 minus 4i over n all squared, right? And this can simplify, all right? So this is going to be 6 minus 4 squared is 16 minus 16i squared all over n squared. So this right here is our f of xi, okay? So now we're going to write this, right? The limit as n approaches infinity of, we have our sigma, I equals 1 to n, okay? Now we write our f of xi, which is this. 6 minus 16i squared all over n squared. Put in the brackets, times our delta x. Our delta x is 4 over n. 4 over n. Now 4 over n can go either here or here, but I like to leave it to the right side. It's just my preference. But once we have this, we're in business. We can simplify it now, all right? So now what we want to do, all right? We want to multiply this times this and this times this. We multiply this times both of these values right here, all right? But when we multiply it, if we have an I value, like we do right here, we leave the I value in front of the sigma notation, all right? So let me show you what this looks like, all right? So now, cannot forget the limit as n approaches infinity, okay? And now 4 over n times 6, this would be 24 over n, right? So then we put 24 over n, sigma notation, I equals 1, n on top, all right? And then since it's 4 over n times 6 and there's no I value, we just put a 1 in the front right there, okay? And now there's a minus sign, minus 4 over n times 16i squared over n squared. Now this is very important right here, okay? 4 times 16 is 64, okay? N squared times n is n cubed, okay? So what we want to do is put 64 over n cubed on the outside, like this, okay? But we leave the I squared on the inside, okay? Anytime we have an I, we will always leave the I in the inside of the sigma notation, okay? So 64 times 16 is 64 over n cubed, n squared times n cubed, and then sigma notation, I equals 1, n on top, and then we leave the I squared, just like that. So this is our expression right here, okay? This is our Riemann sum definition of integral expression right here, okay? So now what we want to do, we want to simplify this to get an answer. All right, so now when we do this, this turns into n here. So this is going to equal 24 over n times n, okay? So this, we have 24 over n, put it right here. This 1 turns into an n because I equals 1, it goes to n, and the 1 would turn into an n, all right? So 24 over n times n, okay? Now we subtract, because we have the subtraction sign here. 64 over n cubed. All right, multiply that. So I squared, okay? I squared has a definition that you just need to memorize. Okay, there's no getting around it. You just got to memorize it. And this definition for I squared is n times n plus 1 times 2n plus 1 all over 6. All right, this right here is the definition for I squared. I has a different definition. I cubed has a different definition, but you just have to memorize them, okay? So once you have this, you're in business. We're going to simplify this now. So 24 over n times n, all right? The n's cancel. So this leaves us with 24, all right? Now this, we need to simplify this, all right? So we need to recognize the fact that we have n cubed on the bottom, and up here, all right, we can, instead of just multiplying everything out and then canceling stuff out, that would take too long, right? So we can just recognize the fact that there are 3 n's here, right? N times n is n squared. N squared times another n is n cubed, okay? So we have n cubed on top here, right? So we can cancel out these n's. These 1's go to nothing. They're irrelevant, okay? You just want to focus on the n's, all right? So n cubed and n cubed up here cancel. However, we have this 2 right here, all right? We need to take that into account. So 64 times 2, all right? So when we have this 2 here, when we have this 2 here for I squared, we multiply this number times 2, okay? And 64 times 2 is 128, okay? So this would be 128 over 6, right? Minus 128 over 6, just like that, okay? And that's, so let me walk you through how you got that again, right? N cubed on the bottom, we have the 3 n's up here, they all cancel. However, we have this 2, we multiply that times the 64, which is 128, and all that over 6. So now we're left with this, okay? Now we can simplify this, all right? Get all over the common denominator of 6, right? 24 times 6. 24 times 6. Let's just do that on the side right here. 144. So 24 times 6 is 144. So 144 over 6 minus 128 over 6, which equals 16, which equals 16 over 6. And this equals, now we simplify this even further, 8 over 3. And there we have it. That's our answer, 8 over 3. Thank you for watching.